So looking at graphing systems of inequalities, it is really just as simple as treating it as separate problems, looking at where each graph would be, what would be shaded, but then we want to find the region in common if there is one. So that's really the only difference is we don't shade everything. We look at what should be shaded, but we find the region in common to all of the different inequalities in the system. So looking at our first one here, this is just two lines, so we'll graph them, starting with this one. I'll subtract the x and divide by a negative, which will switch that sign around. That gets it into graphing form for me. So we'll have a y-intercept at the point 0, -1, and his slope will be 1. So y-intercept at -1, and a slope of 1, like 1 over 1, so up 1, right 1. So we'll have our line going up like that. And this line, look at whichever part of the inequality you want to, does not involve an or equal sign, so we know this is going to be a dashed line drawn. Now, without actually shading, let's talk about, or let's determine which side should be shaded. Let's throw in a test of 0, 0 into our inequality, and that'd be 0 minus 0 is less than 1. So that says 0 is less than 1, which is true. So notice we plugged in 0, 0, and it's correct. So we want to shade up here. So again, notice it's not necessarily always as simple as just reading this inequality and saying, above or below. We usually want to solve for y to see what actually is happening. Y is greater than. That makes sense now. Y is above. Now again, don't shade it. If anything, sometimes I draw, usually in pencil, a couple arrows, showing myself that I was going to shade above. That was the region that should be shaded. Now let's do the same thing for our next inequality. I'm going to subtract the x term and divide by 3. So we're going to have a y-intercept of 0, 4, and a slope of -2/3, which I'll interpret as a negative or a positive to be down 2 and right 3. So 0, 4 is our point, and then down 2, right 3, conveniently intersects there. A nice point, doesn't have to happen. But this line that we're going to draw, notice, has an or equal to in the inequality. So this line will be a solid line. Get that in the camera there. So a solid line going through those points, like so. And with this one, let's pick a test point. Let's do the same 0, 0. So if I test 0, 0, then we're looking at 2 times 0 plus 3 times 0 is greater than or equal to 12. That's 0, that's 0. So we're getting 0 is greater than or equal to 12, which is false. So this line, this point, is not in the correct region. So forget the other line exists. Looking at just this line, 0, 0 would have been all of this, but that didn't work. So we'd want to shade above this line. So I'll draw a couple little arrows saying we would shade above that line. And now you've got 4 regions. This particular graph, these 2 intersections gave us 1, 2, 3, 4 different regions. And the question is, which, if any, are regions that are in both shaded regions? So this line would have you shading this region and this region. This line would have you shading this region and this region. So right here, this is the one area that is both above the dotted line or dashed line and above this solid line. So that would be our solution to the system of inequalities. All right, so the next one throws in a nonlinear equation. We want to recognize that as a parabola, and you can either use the general graphing form of it or you can use the idea of transformations, either way, to see what's happened here. But this parabola has been shifted down 4 units, right? That's y is x squared with a -4 on the outside. So with that, we would say we know where the vertex is. It's a parabola whose vertex is normally a 0, 0, shifted down 4 units. So we know it's there. Let's find a couple more points just for some accuracy, whether you pick x's and plug them in and find y's like an xy chart, or whether you just know a little bit about the x squared function. If you recall, we knew things like from the vertex, the next points, as long as that wasn't stretched or compressed, which it wasn't, the next points are always over 1, up 1, right? We knew those points each existed, over 1, up 1. And we even said the next points were over 2, up 2, over 2, up 4. So over 2, up 4. So there's a good number of points to be somewhat accurate with this graph. So as we draw it, we do again want to remember that it's an or equal to. So we will take and draw a solid graph for our parabola here. Okay. Now let's take a look at where we should shade. Let's just test. And the point 0, 0 is not on our function, so we can test 0, 0. So we got 0 is greater than or equal to 0 squared minus 4. So 0 is greater than negative 4, which is true. So for this parabola, the point 0, 0 is true, meaning we would want to shade inside of this region. So again, I'll just draw a couple little arrows saying we should shade inside. All right, now the other one is just an equation of a line. So let's get this in graphing form. I'll subtract the x and divide by a negative. So we've got the y-intercept at negative 2. So there's that point there. And the slope is 1, which is like 1 over 1. So up 1, right 1. So from there, up 1, right 1, up 1, right 1, or down 1, left 1. Conveniently, a couple nice points that we knew we had here. Now this line is also a solid line, right? With the or equal to. We'll be drawing this as a solid line as well. Oops. Try and draw it as straight as possible. So there's that line. And again, for this line, we want to test. And we can test 0, 0 because that's not on the graph of the line. So testing 0, 0 looks like 0 minus 0 is greater than or equal to 2. So that looks like that's false, right? We do not have that, which means this point 0, 0, again, just thinking about the line, it's not shaded up here, right? So that would mean it would be shaded below. And so with this particular graph, we've got a couple regions, right? I mean, we've got things that are over here, in here, over here, all of this down here, or inside of this little region here. And so just look at where your shadings would overlap. You want to be shading inside the parabola, right? All of this, but you want to be shading below this line. So above the, or not above, inside the parabola, but below the line would mean that that region right there is the region that we are wanting to shade for our solution. All right, let's look at one more. This is just an example with multiple, more than 2 inequalities. It's actually technically got 4 the way it's written, but just to show you, you can work with more than 2. So they're all linear, mostly straightforward here. Let's get this first one in a nice graphing form. So I'm going to subtract the x, divide by negative 1. So that's telling me my y-intercept is at negative 2, and then my slope is 1, which is 1 over 1. So up 1, right 1. So from that point, get a couple up 1 right 1s or down 1 left 1s, and we'll notice it is not an or equal to. So this line should be a dashed line. And if we test it, test at point 0, 0, it'll say 0 minus 0 is less than 2. So 0 is less than 2, which is true. So 0, 0 is good. So for this line, we would want to shade above it. So we'll keep that in mind. Now the next line is really 2 inequalities. This is comparing x in 2 different ways. And I would strongly suggest just writing it out. Write it as x compared to one number, x compared to the other. Always write x first for easy comparison. Meaning when I read this one, this says negative 2 is less than or equal to x. that's the same as saying x is greater than or equal to -2, just like reading it backwards. Read it as x compared to the number, just like this other one is easy to read left to right, x is less than 4. So that would be my suggestion, is to break apart any of those three-part inequalities, because then they're just simply represented as two different excuse me, vertical lines. X equals -2, x equals 4, but they're obviously inequalities. So for the vertical line of x is greater than or equal to -2, we'll be here at x of -2, and since there was an or equal to, we will have a solid line to graph. Also, it was greater than, and remember for vertical lines, greater than means x's are bigger, so x's are to the right. So we'd be looking at shading that way. For the other inequality, x is less than 4, another vertical line over here at 4, however, there was no or equal to. So this vertical line will be dashed, and to be less than, when you're talking about a vertical line, would mean shading to the left. And so, with all that, we've got one more to draw, just a y is less than 3. That'll be a horizontal line located at 3. Since there's no or equal to, that will also be a dashed line. And less than, when you're talking about the y direction, less than is down, less than is below. Now, I know there's a lot of regions, a lot of different arrows going lots of different ways. Just kind of start limiting it. Notice that with this very first line we drew, we only want to shade above it. Okay, so we're shading above it, but we're also shading right of this line, left of this line, and below this line. So the only region, and there can be more than one, but in this case, there's only one region that is above, to the right, to the left, and below. And it's all of this in there. So again, you can check it after you've drawn it, but it's above that line, below that line, right of that line, left of that line. So that would be our final solution.